In today's lesson, we will be using the properties of exponents to simplify expressions written in scientific notation. So in our first set of examples, both of these we are multiplying a number by scientific notation. So basically just multiplying two numbers together, but one of them is written in scientific notation. Now this looks like the distributive property, but it is not, because the distributive property is when you have addition and we have multiplication. So really all this is saying 7 times 4 times 10 to the 5th power. We're just multiplying three numbers together. So you can multiply the two coefficients. 7 times 4 is 28, and then we have 28 times 10 to the 5th power. However, that is not written in proper scientific notation because 28 is above 10. So let's rewrite it in proper scientific notation. The coefficient becomes 2.8, and then times 10. How do we change the power, the exponent? Because the coefficient I had to decrease by 1 decimal place. To make up for it, I have to increase my exponent by 1. So it becomes 2.8 times 10 to the power of 6. Same idea for the second example. 0.5 times 1.2, we can just multiply those two numbers together, which is 0.6. And then we still have to multiply times 10 to the power of -3. But that is also not written in proper scientific notation because the coefficient is less than 1. So if we rewrite it, the front number will be 6 times 10, and then how do we change the exponent? Because we had to write this properly, had to move the decimal place one place to the right to make a larger coefficient. To make up for it, we need to decrease the exponent. And when you decrease a negative number, it's like a bigger negative. So 6 times 10 to the power of -4. Alright, the next set of examples, we're multiplying two numbers where both numbers are written in scientific notation. So let's start with this first example, 2.5 times 10 to the 8th times 6 times 10 to the 3rd. So if you notice, all this is a lot of multiplication. We're multiplying here, and then also we're multiplying here. So if you break it up, it's really just four numbers being multiplied together, and you can multiply in any order. So I'm going to bring my coefficients in front, and I'm going to do 2.5 times 6, and then I'm going to multiply my powers. So times 10 to the 8th times 10 to the 3rd. So all I did was rewrite my four numbers in a different order, grouping them together. So I can multiply the coefficients. 2.5 times 6. 2.5 times 6 is 15. And now times 10. How do I combine? Here I'm multiplying powers with the same base. What is the property of exponents? It tells you to add your exponents. So 8 plus 3 is 11. So 15 times 10 to the power of 11. But 15 is larger than 10, so we need to rewrite this in proper form. 1.5 times 10. Because I had to move my decimal to make the coefficient smaller, I need to increase my exponent by 1. So it's 1.5 times 10 to the power of 12. Alright, so let's do another example. So all this is there are four separate numbers being multiplied together. We can multiply in any order. So I'm going to multiply my coefficients first. 9 times 7 is 63. And then times 10, when I multiply my two powers, because they have the same base, the property says you can add your exponents. Negative 6 plus negative 9 is negative 15. But this is not written properly, scientific notation, so my coefficient I need to change to 6.3. And because I had to decrease the coefficient by 1 decimal place, I need to increase my power by 1. So times 10, and then a larger exponent would be negative 14. Alright, so the third set of examples, we are raising a number written in scientific notation to a power. And you could think of this like it's just a product to a power. So 4 times 10 to the 5th squared, what it means is 4 times 10 to the 5th times 4 times 10 to the 5th. Or the property, when you have a product to a power, says that you can apply the exponent of 2 to everything inside the parentheses. So it becomes 4 squared times 10 to the power of a power, 5 times 2 is 10. And then 4 squared is 16. 16 times 10 to the 10th power. And then rewrite it in proper scientific notation. The coefficient has to be 1.6 times 10. And because I had to decrease my coefficient by 1 decimal place, I need to increase my exponent by 1. So to the power of 11. Alright, second example. Scientific notation to a power, we just get to apply the outside power to both. So 3.5 to the 3rd power is 42.875. And then times 10, multiply our exponents, negative 4 times 3 is negative 12. And now to write this in proper scientific notation, we need to move the decimal place 1. So 4.2875 times 10, and because I had to decrease my coefficient by 1 decimal place, I need to increase my power, so it would be negative 11. Alright, so here is our last set of examples, and we are dividing numbers that are both written in scientific notation. So, what we can do, our front numbers, they're just regular numbers that we can divide. 6.5 divided by 1.3 is 5, and then times 10. Now, when you're dividing powers with the same base, the property says you subtract your exponents. So 15 minus 8 is 7. And this is actually already written in proper scientific notation, so we're done. So now the second one, same thing. Front numbers we divide. 2.7 divided by 9 is 0.3. And then times 10, we're dividing powers with the same base, so we subtract the exponents. Negative 8 minus negative 4 is really, so negative 8 plus 4 is negative 4. So 0.3 times 10 to the power of negative 4, but change it to proper scientific notation, so it's 3 times 10. Because I had to increase the coefficient by 1, I need to decrease the power by 1. So it would be 3 times 10 to the power of negative 5. So there is my final answer. So there's the full lesson on using the properties of exponents with numbers written in scientific notation. Good luck!